IPv4 subnetting. Probably the most difficult topic for people to get a hang of. A lot of people get hung up here. So I'm going to teach the way I was taught, which is kind of like the long form method, I guess you could say. We're going to break things down into binary. Sometimes there's mathematical mental hoops you can jump through to make things a bit easier at times, and there's tricks you can do, but I'm going to teach the way I was taught, which is kind of the core method of doing it. So we've talked about IP addresses and network sizes, and now we have to actually go ahead and make a real, make an actual subnet, make a network of some size. So we can take larger networks and make them smaller. We can take smaller networks and make them larger, even, called supernetting. And we can just design an entirely new network out of the thin air. So let's start out with some history of the way it used to be. And because subnetting technically is built off of this older method. So this older method was called Classful networking. So it was Classful. And what that meant was, based on the first octet of your IP address, remember from before, we were talking about how there's 4 octets in an IP address for IPv4. That first octet defined what subnet mask you got. So you had several different classes. You had a class A, you had a class B, you had a class C, and yep, there was even a class D and a class E. So class A was based off the notion that if your first octet started with a 1 to a 127, you'd get a class A. If it was 128 up to 191, you'd get class B. 192 up to 223, you would get a class C. And class D and E are a little bit special. D was for multicast. Remember, we were talking about those multicast addresses starting at 224. And class E was for that experimental range. It was reserved. So these were actually 224 up to 239, and this was 240 up to 255. So A, B, and C were actually used for real networks, though. And if you had a class A, your first octet was this, you would receive a /8. For the other one, you'd receive a /16, and this one you'd receive a /24. So remember, we have to convert that into dotted decimal notation. If you want to convert that into a subnet mask, this is the prefix. The subnet mask would be then 255.0.0.0 or 255.255.0.0 or 3 sets of 255. So that's where that came from. So if you had a network that started with 72 dot something, you would have a /8. You'd have your subnet mask would automatically be 255 dot something, 255.0.0.0. So it would be 72 dot something. The problem with that is it was very wasteful. So let me write out some network sizes, and you'll have an idea as to why this is wasteful. We're almost done. So back in the day, before there was variable length subnet masks, which is what we are doing here, creating subnets, which is also referred to as VLSM, and with the routing side of things, when you route variable length subnet masked networks, you're doing classless interdomain routing, which is CIDR, C-I-D-R. Those are two terms you'll want to know. So if you were doing this back in the day, and your subnet started with 72 dot something, you'd get a /8, you'd get 255 dot something 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 000 for your subnet, and it's very wasteful because that subnet would have 16,777,000 hosts available to it. So if you take a look at the IANA list of some of the IP addresses that used to be handed out to some of the first organizations that were on the internet, they have these /8 Class A addresses. So that means that some of those older corporations, such as HP Digital Equipment Corporation, so a bunch of the old very large companies, they owned millions and millions of addresses for devices that they had, which at the time they didn't even have that many devices, because back then this was before we had the private address ranges and before we had network address translation where we could hide behind one IP in that. So every device had its own unique address, but even then, that millions of addresses handed out to an organization. Back then, even now, there's probably not millions of devices in use. So it was very wasteful. A lot of areas that were just a lot of empty space. So as you add bits to your subnet mask, as you add bits to your network side, you get more networks with less hosts per network. Down to, in this example, what's a pretty common thing, we have 192.something.168, and that would have 254 hosts. That's a very common network. And you can make them smaller than that, and you can make them larger than that. If you make them larger, if you make a subnet that's larger than these classful definitions, it's called supernetting. If you create a subnet that is smaller than these classful definitions, it's called subnetting. That's really the difference. So what we'll do is we'll go ahead and we'll start learning about how we do this and actually create a subnet and define the types of addresses that are available to us within a subnet. So let's clear this, blank this out here. So remember before I referred to, I mentioned the placeholders. So we're going to write them out. When we're doing binary in octet form, as we do with IPv4, we're going to want to write this out all the time. You're going to do it a lot. So we have different kinds of addresses in our subnet. We have a network address, we have our first host address, we have our last host address, and we have a broadcast address. So we've gone over some of these before, and we've touched on them. But how do we actually calculate that? So I have an address here of 192.168.77.151. My subnet mask is 255.255.255.0. So what does that mean? That means that everything over here on the left side is going to match, and we'll talk about the ANDing process and matching in a minute, a little bit in a few. Everything on the right side is up for grabs essentially, so it's for the hosts, with the exception of two IPs, the network address and the broadcast address. So since our dividing line is here, where at that fourth octet, I'm only going to write out the fourth octet here. So if I were to make all of the bits in the fourth octet 0, that I have available, and I have 8 bits available on my 4th octet because our subnet mask is 24 bits, remember? So I have a full 8 bits to use for my hosts. So I turn all of those 8 bits that I have available from my hosts to 0, and that's my network address. So if I do that, and I make these all 0, we're going to add up the placeholders, which ends up being 0, and that gives me my network address. So my network address is this. That's my network address. If I turn them all to 1, I turn all of my host bits on in my network that I have available for my network, for my host bits, that's going to give me my broadcast address, and that's going to be, if I add up all the placeholders, it's going to be 255. So that's my broadcast address, and I'll mark these. It's my network, that's my broadcast. If I go 1 less, if I turn my 1 bit to 0, but I leave all the others turned on to 1, so if I go 1 less than the broadcast, that's going to be my last usable host. So my last usable host address is this. If I go 1 up from the network, which is all zeros, if I go 1 up from the network address, I turn on that 1 bit, then that's my first usable host address. So that's how that works. So, and it doesn't necessarily have to divide it perfectly at that last octet, but that's an example of how you determine your network address, your broadcast address, and your first and last usable host addresses. It's always based off of turning all of the bits in that you have available for hosts all the way off, all the way on, and then going 1 up 1 or down 1 from that, and that'll give you what is available to you. So, for example, we'll do the example after. So we'll blank this out again. And we'll talk about, we'll get back to that in a minute. So, some way to determine what subnets you need. So if you need to determine, I need to make how many, certain number of subnets. You can calculate that using the power of 2 since it's all based off of binary. So if you want to do number of subnets, let's say, the boss says you need to make, 20 subnets or something like that off of this range. You can do that by simply doing 2 to the power of n, where n is the number of network bits. Or say someone says, oh yeah, you have 4 network bits to work with. How many subnets does that make? You can use 2 to the power of that to determine the number of subnets. If you want to do the number of hosts, it's almost the same thing. Number of hosts is 2 to the power of n, where n is the host bits. If you want to determine, now that's the number of hosts, but that includes the network and broadcast addresses. Because remember, we had to go up 1 and down 1 because we can't use the network IP, the network address, or the broadcast address to actually assign to a host. So if you want to determine the number of valid hosts that you can actually configure, that would be 2 to the power of n minus 2, where n is your host bits. Because you have to subtract 2, 1 for that network address, 1 for that broadcast address. So let's blank this out. And let's say we have to make a subnet. So we're going to write out our placeholders, as we do. And we're going to mark out the number of network bits that are in our octet. So the best way to describe that is, let's say we want to take this address. We're going to take this subnet and we are going to make it smaller. So this was a /24 to start. Let's make that into, a /28. So what does that mean? /24 we divided here. Remember, this is our division line. So all this was network and all this were hosts. Well, with a /28 we have to borrow a few bits from the host in order to make this work. Because remember, when we say /24 or /28, that's the prefix, that's the number of bits on the network side. So that's 8, 16, 24 bits. If I'm making a /28, I need 8, 16, 24, 5, 6, 7, 8. I need to borrow half the bits from the host side. So I need my division line to be over here somewhere. So in order to do that, we're going to be working within this last octet. So when I write them up here, I'm working within this last octet. And I'll make them a different color so it's a little bit easier to see. So let's underline that. So I'm going to make a /28. So we're going to not write down all these bits, because if I were to write all them down, they'd all be ones, because we're talking about network mask. So this would all be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8, 16, 24 bits. And now we're going to need to borrow another 4 from over here. So this is what we're going to be writing up here. So let's write that out. So /24 has already been done, as you see below. So /26, 27, 28. Or, sorry, 25, 26, 27, 28. I don't know what I'm saying. So there's our 4 bits that we've borrowed to make a /28. So we've now borrowed 4 bits. So the other ones are going to be 0 because these are host bits. We're not allowed to touch those right now since we're working on making our subnet. These guys are for the hosts. And these guys are for the network. Our division line now, instead of being perfectly at that dotted decimal spot between the 2 octets, we're now dividing it in the middle of an octet. So this is our division line. So what does that mean? So how do we determine what our network address is now? Because it might not be 0. So how do we actually do this? How do we make a subnet out of this? So what you do is, now that we've made our division line, we can now take a look at what placeholder is right here to the left of that division line. We're going to count by that. And what I mean by that is this. We're going to write out our address, and we're going to start at 0. Now we're going to count by 16 in that last octet. Now we're going to count by 16 again. Now we're going to count by 16 again. You get where I'm going with this? You can keep counting by 16. That's your subnet size. We've borrowed 4 bits from the hosts, so now our subnets are smaller, but we have more of them. So we're going to keep counting and counting and counting, and we'll continue on with that. I'm not going to write all of them out though until we hit the 254, but you'd go all the way down until you hit to 255, for example. This is your network IP, or your network address. So this is what defines your network. Remember before we were talking about a network address and a broadcast address and the first and last usable host address? We can now figure that out by looking at this. So if we look at this, let's say we wanted to, determine the broadcast and usable addresses within one of these networks. It's actually pretty easy now. We can actually look at this. So this, if .16 is our network address, it's going to be 192.168.77.16. If we count one up from that, that's going to be .17, right? So .17 is going to be our first usable address. Our network address we've already determined is .16. So if we count up one, it's .17. What we can do now that we've written out all the other subnets is we can just count down one from the next subnet. The next network is .32. So let's count down one from him. He's .31. That's going to be our broadcast address. And then if we count one less than that, I should have left more room here, it'd be .30. That's going to be our last usable host address. So our network address is 16, our broadcast address is 31, and then the usables are 17 to 30 within that. And then you can do that for every subnet. You could do that for this one too, same exact thing. You could do, the network is .32, the next network is .48, so if we reduce that by 1, that's going to be our broadcast address. He's .47, and then we have first and last usable addresses. It's going to be +1 off of our network address and -1 off of our broadcast address. Pretty simple. So as long as you write out your notation here, your placeholder notation for your binary, and then determine what octet you're working within, you can simply write out the number of bits, make that division line, and then count by that placeholder that's to the left of your division line. And then if you just write them out, you can then simply just -1 + 1, -1 + 1, and you can figure out those 4 types of addresses that you need to know. So let's do one more example somewhere not in the last octet, and I'll show you how it really doesn't make any difference whatsoever. So let's do so. We're going to write out our placeholders again. And let's say we want to use the IP of, I don't know, 10.5.7.3, I don't know. And that's going to be an IP address that we've been given. So this is some sort of host out there. This host has a subnet mask of /18 for some reason. So he is on a network of /18. The question might be, find out what is the network address of this host. So how do we determine that? So in order to determine that, we need to write out all of our bits for our network prefix. So that's 18 bits. So let's write those out. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we're going to be working within this third octet, okay? So let's now take this octet, and that's what we're going to be working on over here. So now we're working within that third octet in this example over here. Let's write out these bits. So we're a /18, so that's going to be this bit, and this bit is going to be enabled. These bits are going to be turned off because they are going to be used for the hosts, as well as the entire last octet is going to be used for the hosts. Our division line is obviously going to be here because that's where the 1s and 0s are divided. This 64 is going to be what we count by. So start at 0. Within the third octet, that's something that people get confused about. We're going to count by from 0 upwards by 64, but in that third octet. Don't do it on the fourth octet. People sometimes get confused. Remember, we're working within that third octet right now because it's a /18, 8, 16, 17, 18 bits, okay? So we're going to count by that 64. So we're going to do 10.5.0.0, 10.5.64.0, 10.5.128.0. You see where we're going with this? So we'll stop there. And then you'd get to you can go up until you hit 255, but we'll stop there. The question would have been, what is the network address, broadcast address, and usable host addresses within this this IP's network? So we've already well exceeded that. So his IP was 10.5.7.3. So we have 10.5.0, 10.5.64. So it's .7, so it's going to reside within this network, right? Because it's not going to be higher than 64. It's higher than 0, but less than 64. So it's going to be within this network. So let's figure out the information for this network. So this is going to be 10.5.0.0 is going to be the subnet, the network address. So the network address is 10.5.0.0. Let's do the broadcast, because that's probably the next easiest one. It's going to be 10.5 dot, and we're going to look at the next network and reduce that by 1. But not by 1 in the third octet. It's going to be by 1 bit. And that 1 bit is going to be in that fourth octet, because remember, we have a whole lot more bits for the hosts now. So we're going to have 63.255. Okay? So we have to reduce it by 1 bit, but it's not in the last octet, essentially. Just make sure you are working within the correct octet when you're doing this. And then if you do the last, we can work off of the broadcast now. And if we want to do the last usable address, that's going to be 1 less than your broadcast. And then our first usable is going to be 1 up from our network address. So as you can see here, with this network, we have a whole lot of addresses available to us. So with that, I'll leave you to working on some of the available resources out there. If you're watching this on a streaming site, I'll include some links to some free resources for you. But that's the basics to creating a subnet, and I encourage you to continue working on it. Please ask questions and be involved in the communities out there to do what you can to learn the subnetting skill. It is definitely worth it since we're still very involved in using IPv4 in the industry.